Welcome back. Let's get started with the code. I am connecting the collab notebook. Once that is done, run the first cell where your Google Drive is connected, because we are going to take the movie plot CSV that we already created. And this is the path where the movie plots file is. This is the one that we wrote code and parsed ourselves, and this is the code that you have already seen, which is just reading the data frame. And once the data frame is read, let's look for Batman Begins, and all we are doing here is getting the Batman Begins movie plot in this variable, nothing too complex. Let's start with our main code. Spacy is already installed in Google Colab, and what we are doing here is we are using the Spacy library and we are downloading the English language model. This is basically the named entity recognition model. The TRF stands for transformers. There are different models, non-transformer models as well, but we are going to download the highest quality model. So the English transformer model gives the highest accuracy when extracting named entities, so we are downloading the same thing here. Once the download of previous section finishes, let's move on to the next section, and in this section we are just importing the Spacy library, and from Spacy library we are also importing Displacy. It is just a visualization library. So this import Displacy is used for visualization. We'll just see it in a bit. And we are loading our transformer model and initializing our NLP object with it. Once that is done, let's just run our Batman Begins movie plot through the NLP object. And what this does is it extracts all entities, so it goes through the pipeline of tokenization and identifying parts of speech, named entities, all the things. And once that is done, let's run this displacy.render. It will be evident once you see it. So essentially we are asking to take entities and just display them. So all the entities and the plot is displayed in a highlighted fashion, where in Gotham City is the location, and Bruce Wayne is person, Thomas is person, Martha is person, 14 years later is date, 1 is cardinal, and again Bhutan is place, Henry Ducard is person, etc. Right? So just like what we have seen previously, where we extract all different named entities from this movie plot, that's what we have done here. And you can look at several named entities and what they're called here if you want to. And what we are going to do here is we are just going to collect only the entities that have the label person or GPE, which stands for location. So we are just collecting named entities that are persons or locations. And how you do that is you just iterate through this doc.ents, and doc is just the object that we created here by passing in Batman Begins plot. And all you do is go through that, and if the token.label is person, we are going to append that to the persons list. If it's location, GPE, we are going to append it to locations. And we are just since there might be duplicates, we are just making them unique. Once we run this, it will be evident. Pretty simply, these are the name tokens, and we have Fox, Early, Martha, Bruce Wayne, Manor, etc. And these are all the places that we came across in this movie plot: Gotham City, Gotham, and Bhutan. And this is already powerful, where you can extract locations and persons from a movie plot. And why is it powerful? Because in our moviepro.ai app, given any movie plot, you can automatically identify the different persons who are there and the locations who are there. So the movie production house can actually plan for casting because they know how many different characters are present in the movie, maybe like 20 or 30, and they know how many different places need to be planned for. Maybe a movie has 10 different locations. So once you get locations and character names, you can already look for casting and locations and plan for that. So just identifying named entities itself can add value to your moviepro.ai product from any plot. And now let's move on to the section how you can convert these names into localized name to a different country. So for that we are going to use a library called as Gensim. So Gensim is a library which contains these word vectors. So here we are using, like I mentioned, Google News word vector, word to vec, and this 300 means the dimension of each word is 300. So each word is represented with a list of 300 numbers. That's what it means. And this is one of the big word vector, which is 3.2 GB etc. in disk size. And for some reason, if this is heavy for you, you can use fast text, but fast text is not trained on that much data, as well as it's not as great as Google News. So usually I prefer Google News. This is very robust. So let's run these two cells, and all we are doing here is initializing the model with this word to vec of Google News. So this word to vec model takes a little bit of time. Awesome. We are done with loading the model, and once the model is loaded, you can easily get the word vector for any given word. For example, in order to get the word vector for cat, all you need to do is this, which is model and cat, and you can see that it's an array of 300 dimensions. So for those who are wondering how does the word vector look like, simply it is a list of 300 numbers, positive and negative, and this is how it looks like. You can assume this is a 300 dimensional vector. And next, the beauty with Google News vector is that it contains not just single words but even multi words. For example, if you have Los Angeles, you can do Los_Angeles and you can get word vector for that. Similarly, if you have Michelle Obama or Donald Trump, usually a lot of word vectors are not trained with combined words, multi words like this. So if you just give Donald Trump, it might not be present at all. But what you can do with Google News vector is that you can do Donald_Trump or Los_Angeles like you see, and that will be the word present. As you can see, it also gives the word vector. Now let's get to our actual comparisons, real world relationships that I've told you about. For example, king minus man plus woman is equal to queen. I want you to intuitively develop an understanding. How it works is that, for example, king minus man could mean royalty, and if you add royalty to a woman, that becomes queen. So just think intuitively like that, and this single line gets us the output queen. All you're doing is giving woman, king and man here. So the positive ones are king and woman, that's what you're giving here, and the negative is man. And what's happening behind the scenes is it is taking woman's vector and adding it to king's vector and subtracting it with man's vector, and the resultant vector is queried with all the word vectors that are present in this model, and the top 10 are retrieved. Let's run this and it will be clear. As you can see, automatically we got the top 10 vectors and queen is the top vector. So king minus man plus woman is equal to queen is preserved. Similarly, let's look at a few more examples. For example, kitten minus cat plus dog is equal to puppy. Again, develop intuition that kitten minus cat could mean some baby animal, and baby animal plus dog is puppy. Let's run this. Almost it looks magical, and we got the correct answer as well at the top, puppy. And now let's get to the point of localization. For example, idli is a popular Indian dish for breakfast. It's like rice pancake, and if you just do again idli minus India plus USA, you will get back relevant items, and the top item is blueberry cheesecake. Again, intuitively think about idli minus India is almost like a breakfast item or snack, and you are adding that to USA, and breakfast item or snack for USA is blueberry cheesecake. Let's run this. Awesome. Blueberry cheesecake is the top one. It looks magical, but this is true. The relationships hold, and the beauty is that you can even change this to, for example, China, and run it. And you are getting, as you can see, roast duck, glutinous rice balls, cow, bean curd. Pretty impressive. For example, Singapore. Nasi goreng is a famous dish in Singapore, and that's what you're getting. And bakute, char siu, satay, chicken satay, and other things. Awesome, you're getting very relevant ones. As you can see, let's change back to USA itself. So that's the beauty of this. You can change this to maybe France, and you will get baguette and other things. Yeah, cassot, jambon, debof, soccer, great, crepes, etc. Awesome. Now you got the point. That's the power of word vectors. And what you can do is you can keep this general format of USA and India and give, instead of idli, a name, and that name will be converted into India as well. That's exactly what we are doing here, which is, let's run this and it will be very evident. Beautiful. What we are doing here is we are taking Falcone, and similarly we are running it through the most similar. Instead of USA, India, instead of idli, we are giving Falcone, and we are getting back Indian names like Kanoria, Junjunwala, Mukherjee, and Ra is Jamnaki, Vikramaditya. Joker is Raj Kapoor, Mera Naam, Amitabh Bachchan. Rachel, we have Trisha, Rashmi. So I'm getting the top 10 names. And Thomas is again Ramaswamy, etc. Not all words are present. For example, like I mentioned, if there are double words, you can give underscore, and again I'm just replacing underscore. So Alfred Pennyworth could be like Krushida or Gemini Ganeshan, Ravi Baswani, all Indian names. And some words might not be present in the vocabulary, so there are no results for it. But the beauty is you can take all these 30 or 40 names and automatically find similar names in an automatic fashion or semi-automatic fashion. And what I mean by semi-automatic is this. For example, you might not get the correct word that you want right away in the first answer. So simply you can build with this IPython widget a selector, drop down selector. As you can see, Fox here is name, but the word vectors are trained such that Fox is a news channel, and Indian news channels are here like NDTV, Doordarshan. And for example, early is VK Singh, but you want it to be Mukherjee. Falcone, you want it to be, let's say, Kamath, etc. So what you can do is you can create like a beautiful drop down interface, like a semi-automatic way. Let's change Rushida to, let's say, Ravi Baswani, and once these drop downs are selected, you can just store them. And as you can see, for example, we can see that Alfred Pennyworth is with Ravi Baswani. So similarly, all the names are replaced with their corresponding Indian names. And now simply you can go back to the original movie plot. Wherever Martha occurs, you can replace that with accordingly. For wherever Alfred Pennyworth occurs, you can replace that with Ravi Baswani, etc. Some words might not be present, so you need to manually do that. But apart from that, you get the point, which is you can replace the names, or similarly you can replace the places, for example Los Angeles and other things with their corresponding names, and automatically localize a movie plot. So you can adapt a movie plot in one click, or with one click and some semi-automation in drop-down selection. You can localize a movie plot, a Hollywood movie plot, to Bollywood or China or Korea, etc. And similarly, let's just see if you just replace this with China. The beauty is that you'll get again similar name suggestions. For example, Bruce is like Leeway and Shaw, and for example Thomas could be Lee Hu, Liu, Zhou, etc. Or Alfred Pennyworth could be Chan Kwok Kwan and Liu Ye, etc. So it saves a lot of imagination for you, where you can automatically find relevant adaptations of the names or locations without you putting too much work. And this could be a great starting point before you completely adapt the movie plot. And thanks a lot. I hope you learned something new, and the power of word vectors is very evident. As you can see, it preserves the real world relationships that we encounter. Thank you.